Welcome to lesson 106, complex figures. Up on the board I have a polygon, and this polygon is six-sided, so it is therefore a hexagon, right? 1, 2, 3, 4, 5, 6. And you'll notice that this hexagon's very interesting. It doesn't have all equal sides. This bottom line is 16 centimeters, 10, 10, 5, and there's even some missing sides right here and here. And the goal is, can you find the area of this polygon, this complex figure? Now, you know the area for parallelograms, base times height or length times width, and you know the area for triangles, right? Base times height divided by 2 or length times width divided by 2. But you've never done a hexagon or any complex figure like this. So here's what I want you to think about. Use what you do know to find out what you don't know. You do know the area of parallelograms. Do you see that this shape is made up of parallelograms? We have one right here, and we have one right here. If you could find the area of the big one and the small one and just add them together, then you have found the area, okay? It's a very visual lesson, but because for some students it's hard to figure out what the missing sides are, I'm going to show you a method I would use to be the most careful, and that is to separate it into shapes that you know, okay? So watch how I do that. Here's a square, and here's another rectangular shape. I'm going to separate them apart and find the area of each one. So this shape, I'm just going to redraw it right next door with 5 on the side. Okay, now base times height or length times width is area, right? Well, look at this shape. 10, 10, 16. What's the area of this shape? Would it be 16 times 10? Or would it be 10 times 10? The answer is 10 times 10. If you recall, this 16 is not the length of this side. It's the length of this side plus this missing piece here. So this 16, this doesn't go here anymore. This whole side is 10, and this whole side is 10, so its total is 100 centimeters squared. And when you're finding the area, you need to know 2 full sides. Not a part of a side, you need both full sides. One full side times another full side will give you the area. Now what about that small shape? We only have the 5. We are missing numbers all around. As long as we can get 1 on the bottom or the top, because they're the same, we can find the area. So how would we figure that out? Well, if you recall, this whole side was 16. So the piece here plus the piece here add to 16. Well, this side was 16 and it's now a 10. Do you understand how it's now a 10? The 10 here should match the 10 here. So to make 16, how much is missing? 6 more. So this missing piece now is 16. Is 6. So 10 plus 6 make 16. Now we therefore have the 6 times 5, which makes 30 centimeters squared. Put them together and you will have your answer. The area will be 130 centimeters squared. Don't forget to write centimeters square since you're looking for area. Okay, now let's try a different one where you have to find the area and perimeter. Okay, you ready to find the area and perimeter? Let's start with perimeter. Perimeter is just the distance around something. It's like the perimeter of the school, the perimeter of a fort. If you were to search the perimeter, you would go all the way around. And I think with complex figures, you've done this before, right? So let's say you were standing in one spot, and this was you, and you need to go all the way around. You walk this distance, you would have 15, and then you walk this distance, you would have 19, and then 12, and then 10, and you're back to where you started. Add them all up. 10 plus 19 is 29, plus 15 is 44, plus the 12 that we're missing is 56. and it is centimeters. Now it's not squared because it's length, right? It's the length around, so just 56 centimeters. Now for the area. Now for the area, if you remember, I told you you need to find what you do know, okay? We don't know how to find the area of this crazy shape, but you do know how to find the area of parallelograms and triangles. Do you see a parallelogram and a triangle here? Here's your parallelogram, here's your triangle. Now, what if I try to do this without separating the shapes? Okay, that is very confusing for some, but follow me, see if you can see how I see this. A parallelogram's area is a side times a side, right? Top times the side, length times width, base times height. Well, you have to have full sides for that. This 19, this is not representing the full side of this shape. It's the full bottom of both put together. So I do not want to use the 19 for the area. But here I have a full side, a 12, and on the top I have a full side, a 10. So that full side 10 times the full size 12, full side 12 multiplies to make 120 centimeters squared. Now I'm missing the triangle. Now the triangle is 1/2 the base times height, right? Base times height divided by 2. Well, I have no height and I have no base. So how am I going to figure those out? Well, if the triangle's height is the exact same height as the whole shape, well, it's just the same number, right? The 12 here equals the 12 here. So this will be 12. And then the bottom, what about the bottom? Now the whole thing makes 19. But I've used part of it in the parallelogram, right? 10 carries down, and this is 10 as well. So if this portion is 10, what's the missing piece of my 19? 9, right? This would be 9. So the bottom is 9 of my triangle. My height is 12. And then you have to remember what 9 times 12 is. It is 108. 108 divided by 2 is 54 centimeters squared. And if you add 120 to 54, you're going to get 174 centimeters squared in total. Okay? Now these complex figures are named such because they are complex. A lot of students struggle with this. Okay? If you find yourself getting answers wrong or you're confused, first step would be to separate the shapes. Draw them as 2 or 3 separate shapes. Okay? But other than that, I would be glad to help. So let me know if you have any questions. Thanks.